Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.44. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Electrical power calculation formula will also be utilized while solving this problem. Basic equation of electrical power calculation formula is P equal to V multiplied by I, where V is voltage across an element and I is current through that element. Now move towards the problem. Exercise problem number 2.44. Find power absorbed by dependent voltage source in given below figure. This is the circuit diagram of given problem. We have to find power absorbed by this dependent voltage source. We know that in order to calculate the power of dependent voltage source, we should have at least two parameters. One is voltage across this dependent voltage source and other one is current through this dependent voltage source. Right now we don't have both parameters related to this dependent voltage source. So first we will try to find out these both parameters. Later on we will be able to calculate the power of this dependent voltage source. You can also see that this is a closed loop circuit, so we can use Kirchoff's voltage law to calculate voltage across this dependent source and current through this dependent source as well. Current of this series network that is labeled as Ix along with its direction. The direction of current Ix is clockwise direction. This same current will also flow from this dependent source because of series connection. If we succeed to calculate the value of current Ix, we will be able to calculate voltage across this dependent source as well, because the voltage of this dependent source is also depending upon the value of current Ix. So we will apply KVL to calculate the value of current Ix inside this closed loop. Before applying KVL, first we have to make polarity notation across these resistances according to the direction of current Ix. We know that current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign according to passive sign convention theory. Write KVL equation for this closed loop. Start from this dependent voltage source. Current entering terminal is positive, so voltage across this dependent voltage source, that is 2000 multiplied by Ix, will be taken with positive sign. Next element is 10 kilo ohm resistance. Current entering terminal is positive, so voltage across this 10 kilo ohm resistance, that is the product of current Ix and the value of resistance 10 kilo ohm, will be taken with positive sign. Next is 6 kilo ohm resistance. Current entering terminal is positive, so the product of Ix and 6 kilo ohm will be taken with positive sign. Next is 20 volt source. The current entering terminal is negative, so 20 volt will be taken with minus sign. Next is 4 kilo ohm resistance. Current entering terminal is positive, so the product of 4 kilo ohm and Ix will be taken with positive sign. Next is 60 volt source. Current entering terminal is positive, so 60 volt will be taken with positive sign. And last one is 10 kilo ohm resistance. Product of Ix and 10 kilo ohm resistance will be taken with positive sign because current entering terminal is positive. Now solve this question. Take the products of Ix and the values of resistances. The equation will become 2000 Ix plus 10k Ix plus 6k Ix minus 20 plus 4k Ix plus 60 plus 10k Ix equal to 0. Add values that includes variable Ix together. It will become 2000 plus 10,000 will become 12,000 plus 6,000 become 18,000 plus 4,000 will become 22,000 and plus 10,000 will become 32,000. So the equation will become 32k Ix minus 20 plus 60. Now subtract 20 from 60. The equation will become 32k Ix plus 40 equal to 0. Place plus 40 on the other hand side of equal, the equation will become 32k Ix equal to minus 40, and divide on both sides with 32k to calculate the value of current Ix, that will become minus 1.25 milliampere. Here minus sign along with the value of current Ix is indicating that the direction of current inside this closed loop circuit is taken in wrong direction. The actual direction of current Ix inside this network is counterclockwise. We have calculated the value of current Ix, so we can calculate voltage across this dependent voltage source, that is depending upon the value of current Ix. And the value of voltage across this dependent voltage source is 2000 times Ix. Place the value of Ix inside this equation. The equation will become voltage of dependent voltage source is equal to 2000 into minus 1.25 milliampere. Now take the product of these two values. The voltage will become minus 2.5 volt. Up to this point, we have calculated voltage across this dependent voltage source, that is minus 2.5 volt. Value of current Ix is already calculated in previous step, that is minus 1.25 milliampere. And this current Ix is flowing also through this dependent voltage source, so we can calculate the power of this dependent voltage source. Power calculation formula for this dependent voltage source will be PD equal to Vd multiplied by Id, where Vd is voltage across this dependent voltage source and Id is current through this dependent voltage source. Place the values of Vd and Id. Vd is minus 2.5 volt and Id is equal to Ix, minus 1.25 milliampere. Take the product of both values. Power of this dependent voltage source will become 3.125 milliwatt. So this dependent voltage source inside this circuit is absorbing power of 3.125 milliwatt. This was exercise problem number 2.44. Thank you. See you again in next video.